quiz number 1 explanation. So this is the problem. Solve for the value of the capacitor initially connected in Y having 25 microfarad from a 220 volts 3-phase 60 Hz supply. Take note that the value of the line current should remain constant when the connection is made delta. So to solve, since in Y connection IL is equals to the line current is equals to the phase current, and the load voltage is equals to the square root of 3 times the phase voltage. So to get the IL, just simply have this equation, the phase voltage divided by the capacitive reactance. So to get the phase voltage, since we have the value of load voltage, which is 220, we have now the we can now equate EL of the square root of 3, 220 divided by the square root of 3. Our phase voltage is equals to 127.01 volts. So we have now the value of the value of XC, or the capacitive reactance. So to get the capacitive reactance, we have this formula of 10 raised to 6 2 pi FC. Substitute, since we have now the 10 raised to 6, and still we are still in Y connection. So we have the value of capacitor, which is 25 microfarad, and the frequency, which is 60. So we can now solve the value of the reactance, capacitive reactance. So 2 pi times 60 times 25. So calculator, we got the value of 106.1 ohms. So we have now the value of the phase voltage and the reactance. So substitute 127.01 over 106.1. So calculator again, we got down the value of 1.197 amperes. So IL. So we proceed now to the delta connection. So the problem states solve for the value of the capacitor when connected in delta. So the formula for capacitor, solve for capacitance is this. So the missing value is, since we have now a frequency which is 60, but we don't have the value of the capacitive reactance in delta, so we need to get it first. So since the rules in delta connection, IL is equals to the square root of 3 times the phase current. So that's like the clue. And the EL is equals to the phase voltage, or the load voltage is equal to phase voltage. So to get the XC in delta, we have the formula of EL over the phase current. Since we don't have the value of the phase current, so to get the phase current, we have the formula of the line current divided by the square root of 3. From this formula, we can come up this. So, since the formula said the line current should remain constant when connection is made to delta, so we have still the value of the line current is 197. So we can now have the value 1.197 divided by the square root of 3. Our phase current is equals to 0.691 amperes. So since we have the value of load voltage, which is 220, so when we have now the value of the phase current, so 220 divided by 0.691. So we have now the value of our capacitive reactance. So calculate, the value is 318.3 ohms. So we have now the XC, so we can now solve this. So we can now solve the value for the capacitance. So capacitance is 2 pi, since I have the frequency of 60 hertz and 60, and now you have now the value of the capacitive reactance, so 318.3. Our capacitance in delta is equals to 8.3 microfarad.